south of there in Washington State and Oregon State. And that's because anything that makes a calcium carbonate shell has to work much harder to find the carbonate, the thing that's going down, thanks to CO2 dissolving. There's enough calcium around, but it's not that they can't make the shell, it's just they have to work much harder. So in simple terms, energy is being diverted from procreation and growing in order to just maintaining these calcium carbonate shells. So that's already been observed in the oyster industry. People are very worried about this very crucial food source in the ocean, which is pteropods, little sea snails. And they are food for a lot of things like juvenile salmon and so on. And under laboratory conditions, which simulate the so-called high CO2 world that we seem determined to create, these pteropods don't grow properly and eventually become very small and develop gaps in their shell. And pushed to extreme, eventually the equilibrium will be such that the shells will dissolve rather than be able to grow. Now, we're a long way from that point right now. But a lot of us, myself included, think that we don't want to get anywhere near that point. That would be messing with a very fundamental part of the life in our ocean, such a vital food source. We know from the historical record, the paleo record, that about 55 million years ago, natural phenomena, much slower than is going on with man-made global warming, pushed the ocean temporarily into a state where calcium carbonate organisms couldn't grow. And it's not that the ocean then was dead, it's just full of silicate forms. But the life in the ocean then was completely different than it is now and before or since. And from a precautionary principle, people like me think we just shouldn't go anywhere near that kind of concern. Now, what's happened over the last year or so is some very clever experiments have been done. Some coming out of the Carnegie Institution that were just published in Nature this week, and others also published this week by my former CSIRO colleagues, Richard Mateer and others. And people are getting quite clever about trying to figure out exactly how this lack of carbonate ion will affect the growth of, say, coral reefs. So what the Carnegie Institution people did is, rather than try and look at what's going to happen in the future by increasing the acidity of the water, they went out to a controlled piece of the reef and actually decreased the acidity back to where it would have been if we hadn't been emitting CO2 in the atmosphere. So instead of adding acid to the water, as a lot of people had, they very cleverly added lye to the water to shrink that hydrogen concentration down 30% back to where it would be if we'd left nature alone. And what they found will be tested and verified by lots of other scientists, but what they reported in Nature is that the reefs grew much quicker under natural conditions rather than the fake ones that we've made.